Okay, hello. So today we're going to be talking about um, epoxide ring opening mechanisms. So essentially, epoxide ring opening mechanisms are essentially an example of an SN1 reaction. So let's try to like just what do you call this one? Label it, okay, so that we won't get lost in the middle of the discussion. So it's an SN1 reaction. So when we talk about SN1, there are two things that come into mind. Okay, so number one, it prefers bulky substrates. Okay, and then secondly, it is a two-step mechanism which prefers the most stable carbocation. But before we get into this, because ano, because the this entire diagram kind of looks like especially for a for a new student, you would get kind of lost with how these molecules look like. Okay, but like okay, let's like try to draw how an epoxide ring mechanism is going to look like. Okay, so let's get have an example here. So this one. So I have an O. Okay. And then usually for an epoxide mechanism to continue, or for the epoxide opening mechanism for it to continue, usually need a good nucleophile for that one. So in such cases it could be cyanides, could be alcohols, could be amines. So for example, we'll just use an amine here, or a cyanide for example. Okay, so plus HCN, and then there's a reaction. So the first thing that you need to look at, the first step of this reaction usually is the protonation of the most substituted carbon, which is this one. Okay, could be either side, but since this one is much nearer, this is going to be the carbon of our interest. Okay, so the first step is the protonation of the most substituted carbon, and once it protonates, the ring is going to open. Okay, and after protonation, through backside attack, rather, ah, I'll just BSA to make it short. Okay, and then lastly, what's gonna happen next is that once this one is already protonated, the ring is going to open up, and this one is going to detach. Okay. Now, since there is a positive charge on this carbon over here that's going to cleave away, there's going to be a formation of a carbocation. Okay, so carbocation, and then your nucleophile is going to attach next. So CC, then your nucleophile. So that's just how it is. Okay, and then lastly, thirdly, is the another protonation step, or it could be an acid workup to make sure that your O has its own H. Okay, so okay, for this one, for this case over here, okay, let's try to draw step one. Okay, protonation. So you have your ring here, and then Usually, because this happens in solution, it's already given that your nucleophile or your reagent is going to dissociate into its constituent ions. So this is H plus and Cn minus. Okay. So once it's okay, obviously it's I know it's already dissociated in solution. We'll look at H plus first. Okay. So H plus, and it's going to attack this carbon over here, which is your most substituted carbon. Okay. Now once this one opens up, it's gonna look like this. Okay, because it's gonna let go of this oxygen over here, and then since this one is just a um since this one attacks here, another electron also jumps on this side. Okay, that freeing up this bond over here. So you have a terminal carbon already. Okay, then you have an O minus. So what's gonna happen here is that you have an O minus, and then 1 2 3 1 2 3, and then this you have uh a carbocation on this side. Okay, because it already opens up, it cleaves up. Okay, once the H is already here, but we'll try to like visualize this one. Okay, so if the H is already attacking here, let's try to like put a red here because this one is a CC, an sp2 hybridized carbon. Okay, so C, then you have an H on this one, on this carbon over here. Oops. And since this one also, since this one is going to be free, its electron is going to jump on this carbon over here. Okay, so this carbon over here essentially becomes CH2. Okay, because it cannot accept another H over here because it's going to be bulky, so it's gonna transfer. And once it transfers, it's gonna open up, resulting into this intermediate over here. After the formation of the intermediate, your carbocation is going to be attacked by your other part of your nucleophile, which is your cyanide ion. Okay, so it's just going to be simple. So that's Cn minus, then O minus, 1 2 3, oops, Cn min. Okay, there we go. So that's already complete already. What happens next usually is an acid workup or a hydration mechanism in order to regenerate the hydrogen bond on your oxygen, because this is your this is a very unstable na ion. Okay, so H plus work up, then you're gonna create an alcohol. Okay, so OH, 1 2 3 Cn, triple bond N. So this is your product of this reaction. Okay, on this reaction as an example that I gave. So hopefully that's already clear. Okay, so firstly, let just as a recap, first step of your epoxide ring opening is the protonation of your substituted carbon, most substituted carbon, so over here. And once that is attacked, another electron jumps. So once it jumps onto this carbon, onto here, it frees up the carbon. Okay, and once that frees up, the other part of your nucleophile is going to attack the carbocation, and then there's going to be the formation of another ion, which is then stabilized by your acid workup, which is this one. So let's try to solve the problem above. So let's erase this one for a while. Whoops. Ah, it's lagging. Okay. So the board is now clear. Okay. So let's try to understand this reaction first, okay? Because on your handout or in your book, it says here that metoprolol is actually a beta blocker. So this is usually used as a medication for those with arrhythmia, usually for like cardiovascular na mga, what do you call this one, na mga complications. Okay, so usually it starts with this type of substrate over here, which is an epoxide. Okay, because of this ring over here. Now, as what I discussed earlier, we'll have to like look at the carbons. Okay, now the thing is that, as what I discussed sa previous videos, I already told you na if you're going to look at a reaction, especially involving like molecules such as this, na might seem bulky and at the same time, it might seem kinda, what do you call this one? Kind of very confusing. I think, like you need to just heed the advice lang na if you're gonna look at a reaction, just look at the atoms that are colored, because those are kanang just the indicators lang as to which part or which functional group of your molecule is going to participate in the reaction. You don't need to complicate things further, okay? And then you need to also like respect or also look at rather the direction of your electrons as indicated by your arrow pushing na mechanisms. So again, since this is an epoxide opening na reaction, it is an SN1 reaction. It prefers bulky na molecules. It's two-step, and then it regains its stability. Usually, again, as what I said earlier, for epoxide opening mechanisms, it usually needs a nucleophile for that one to attack the carbon on this side, which is attached to your O. Okay? So, since mo ni siya ang this is a substituted na carbon, it's gonna do a backside attack uh, on that one. Okay? So, let's try to visualize this one. So, for the sake of like, simplicity, we'll just cut the molecule here. So let's just like let's assign the rest of the molecule as your R group, okay? So this is your R, then attached to your epoxide ring, O. Okay. So this is your nucleophile. So your nucleophile is an amine, okay? So it's a dimethyl or it's a methyl ethylamine or dimethylamine. Okay, so let's draw this one. Okay, plus your H2N attached to your C. Then I have an H here. Then I have two methyl groups here. Okay. So, okay. This is your nucleophile. Now, as what I said earlier, the first step is your protonation, diba? So, the H here of your amine group is going to donate its H first onto this carbon over here. Okay? So, it's gonna attack this side. Okay, but let's answer this one first. Why is it not gonna attack here instead of this one? Okay? Because if it's going to attack here, it's just going to prolong the reaction further. Okay, so it's much more mas pabor sa imong imine to react on this site instead so that the electron can jump immediately and break the ring. Okay? So first thing is your, again, protonation of this carbon over here, which then jumps the electron, breaking free your this ring over here. Gets? What's up? What's gonna happen next is that you have your R group here. So you have your R, and then so you have an O minus here, okay? Because this one is already freed, and then since this one is already broken and already detached from your oxygen here, it's gonna create a positive na carbocation. Now we're gonna look at the rest of the molecule of this one, okay? So for methylethylamine, what's gonna happen is that since this one is just NH, HN, I'll just assign an R group for this one as well. It has a minus charge, which then attacks this carbon over here, okay, forming the intermediate that we see on this side, okay, forming the intermediate, okay. But why is it na H diri okay? Why is it na H? Because the H is actually just jumping around. So once this one is already attacked by your other part of your nucleophile, the H plus is just going to return. Same as earlier, okay? Because this is step 1, step 2, and step 3. Gets? Just the same as earlier. So there is a regeneration of your alcohol. There's a generation of an alcohol group because of your free na proton sa iyong system. Okay? So after that one, we already we satisfy already all of the steps for an epoxide ring breakage or cleavage. So first step, the protonation, it's already deprotonated, and then your nucleophile is going to attach to that positive carbon, and then the H is then attached to your O, forming an alcohol. So I hope it's clear. So in essence, after an epoxide opening reaction, it's just gonna stop here. But we see here that it's actually reacted further with H2, hydrogen gas and an appropriate catalyst, which kicks off this functional group over here. Well, that is not exactly kanang necessary anymore to talk about, especially in epoxide opening reactions. We might as well just just look at this reaction, okay, and also try to understand what's happening, okay. So let's try to zoom in. So your H2 over here, okay, so your H2 over here is kanang any catalyst. It could be palladium over carbon, I think, usually because that's usually a common catalyst for hydrogenation. But for this one, it kicks out this carboxylic acid over here, this ester, ether. Wait, yeah, it's an ether group. It's an ester, I'm sorry. So it kicks out this ester group, generating an a carboxylic acid. So what's gonna happen? What is happening here? Okay. So again, it's nice to look at kanang your catalyst and your H2, especially with this type of catalyst as as like this. So usually any catalyst for hydrogenation, you need to imagine this one as a particle of your catalyst, which is dayon, which is going to bond with your H2. So there are bonding sites for your H2 on that particle of your catalyst, which is then going to be the one that's going to attack this part of the molecule. Okay? Why am I certain that this is going to be the point of interest for the molecule? We already know na for like reactivity, we already know na kanang carbonyls, especially this one, are for for only for reductive na mga reagents, whereas this one can be easily attacked because it's open, and its orbitals are free for attack as well. So what's gonna happen is that magdala ang imuhang catalyst padulong diri it's gonna uh you have a proton here that's gonna attack, and then it's gonna jump on this one, forming a negative charge on this side. Okay, so let's try to like put a negative here. Okay, so forming a negative charge on this carbon over here, and then your O is going to detach as well as an ester. Okay, so this is your ethanoate group. Okay, so you need to keep in mind that you have two H's here. Okay, so once this H attacks, it already occupies the space over here, so you already form your acetic acid as your first product. Okay, so your first H is already gone, nawala na. So you're left with another H plus. So this H plus is going to attack this negative carbon over here, forming a CH bond. So I hope that's clear enough. Okay, forming your product na metoprolol. So I hope this is clear. Okay, and if you have any questions, just don't hesitate to PM me, and then like those things. Okay, so I'm gonna upload this one to YouTube. Hopefully it's understandable for everyone. Okay, so bye bye.